Hello and welcome to this video. If you want to build a large 10-inch long-range drone yourself but don't know how or have problems setting everything up correctly, then you have come to the right place. In the video I will mainly show you the Betaflight setup part because that was the more complex part for me. Nevertheless, I will show you the construction process first. First I will explain to you the components that I installed in my drone. Of course you don't have to buy them exactly, but it is a suggestion from me because the parts are relatively cheap but still have a high quality. In general, if you want other comparison data in addition to my data, check out iFlight's website for their Helion 10, as this drone is the same size and has the same requirements. For the frame I decided on the REKON 10 Pro from REKON FPV because I didn't really find an alternative. This frame has the advantage that the front arms are set back and therefore do not cover the camera. For the motors I choose the 2812 900 kV variant. These motors have a peak power of almost 1500 watts at the current of 40 amps. I use 10-inch props that are made of nylon fiber reinforced plastic. Unfortunately, I had to change the stack during the test phase. First I wanted to install the capacitor F405 with 50 amps max current. However, I burned out the 5V BEC output from this stack, and that's why I decided on the SpeedyB F405 55 amp stack. This has really impressed me so far and there are no longer any problems with this FC. As a video transmission system I use the classic DJI O3 Air unit. I also use this for the later YouTube videos because I can save the weight of a GoPro. For the battery I choose the ZOP power with 6000 mAh. I was hoping for a 35-minute flight time. You will find out what flight time I achieved at the end of this video. I choose the M100 5883 module as the GPS module and I bought the beeper directly with the frame. Now let's start building. First I put all the parts out of the box and checked for damage after transport. I also roughly laid the frame down to get the feel for the whole thing, because the instructions here were very bad. After I assembled the frame, which was relatively difficult due to incorrect holes in the carbon parts that I had to re-drill myself, I placed the stack in the middle. Then I attached the motors with M3x16 screws, which were not included in the set. After attaching the props, I took a few pictures with my small DJI drones to capture the size of this huge drone. After soldering, which is really self-explaining, I set up the motors in Betaflight to test them, but I will go into more detail about this later in the Betaflight part. As the pre-last step I soldered on the beeper and the GPS module. Attention, and this is very important when installing the GPS. You must note that the TX cable from the GPS must be soldered to the RX pin on the FC and the RX cable from the GPS to the TX pin on the FC. If you're wondering when I will install the receiver for the remote control, I don't have one. I will start with the O3 because that's possible too. If this reduces the range, I will add this in another video at a later date. Finally, I attach the top plate and place the drone with battery on the cart. At around 1800 grams, it is no longer lightweight. If you attach two batteries, which is quite possible and is also intended by REKON FPV, you can quickly exceed 2 kilos. At first, before you can start in Betaflight, you have to configure the ESC. Therefore, you go to your internet browser and type in BlueJ ESC, or you go directly to the link in my description. After this, you go to connect, but here it is important to close Betaflight in the background, because otherwise it won't connect. After this, you go to read settings. Here you can adjust the switches and slider like I did. On the most of the settings I left on default. The motor direction is set to normal and the LED configuration is set off. After this you can go to flash all. On the first, there you select BlueJ if it is supported by your ESC. The next window should appear automatically depending on your ESC, and for the version you select the newest. After this process you should come to this window. Here you can test all motors separately like in Betaflight. But attention, please remove the propellers. After this we are finished here. Now we can change to Betaflight. Now I'm here on the Betaflight homepage. After you have connected your flight controller to the PC, you go to the firmware update up here. You should set the switches the way I have them and then go to auto detection here. The name of your flight controller should then appear. Of course you should use the latest version. For the radio protocol I choose S-Bus for the DJI Air unit. If you use Crossfire or anything else, then you have to choose your protocol. For the engine protocol I selected D-Shot because that is the most commonly used. For the other options all the functions should appear themselves, depending on which FC you use. Then you have to click on load firmware and then flash firmware. And here I had my first error. After a long search on various websites I found a solution. My drone lost connection to Betaflight while flashing. I then solved this problem with the Zadig port configurator version 2.9. Here I have installed a new USB driver for the port to which I connected the USB-C cable. I also included the link for the download in the video description. If everything worked, all you have to do is go to connect and you will see this screen. The first time you connect you will get an error message, which you can ignore. Now place your drone on a flat surface to calibrate the acceleration sensor. If you move your drone now, exactly that should also be shown here in Betaflight. Next we go to the tab with the connections. Here you basically select which device on the drone is connected to the FC on which RX and TX pin. It is now the case that the air unit is connected to UART1. This means to R1 and T1. Here you also select VTX on the right side. For UART2 I selected the serial receiver. This means that the S-Bus cable goes from the air unit to the R2 pin on the FC. The flight controller then receives the instructions from the remote control via this cable, which are received via the O3 antenna. For example, if you now have a Crossfire receiver and you have soldered it to the R3 pin, you switch on the receiver at UART3. It is also important that not two UARTs have selected the receiver, as this can only be assigned once. For example, you would also have to select the GPS here, but I will get to that in another video because I don't have the new GPS module yet, and the old one doesn't work for this drone. With UART5 the ESC is also selected here. This is specified by SpeedyP as the FC receives the data from the ESC. There isn't that much to say in the basic configuration tab. Here I entered a camera angle of 10 degrees. This value is not 100% correct, but it simplifies the control of the drone. I choose 180 degrees for the arming angle, so that the drone can take off if it lands upside down on the rock. and I can't reach it, so it's possible to get the drone upright again. Otherwise, there isn't much to say about the switches. The GPS function is of course still deactivated here. You would have to switch it on for GPS. And here on the right side you will only find the switches to set which scenarios the drone should make a beeping noise. In the next window you can enter the minimum cell voltage at which the pilot will be warned, but I haven't changed anything else here. In the failsafe tab I selected landing mode on the right. However, this only helps to a limited extent because the FC doesn't know when the drone is on the ground and should stop the motors. To do this you have to set the value yourself. I selected 1 second, which isn't much. However, the landing mode is only a temporary solution until the GPS module is available. Here you can then select the height that the drone adds to the current height. The drone then flies back at this height. To do this you then have to specify minimum and maximum gas values and the pitch angle. I will go into more detail about the GPS rescue function in my video, so feel free to subscribe to my channel so you don't miss the video. In the next tab you select the preset for the DJI O3 Air unit. This then enables the OSD that is displayed in the classes. Things now get more complicated again in the PID tab. I left all the PID settings at default, which worked very well. On the right I have set the engine output limit to 75% in order not to have full performance at the beginning. I changed a few things in the window with the weights, which solved the problem. In the beginning, when I tried to take off, the drone always turned away or made another strange unwanted movement. Here I then set the maximum weight from 450 degrees per second, which corresponds to more than 1 rotation per second around a specific axis, to 300 degrees, which is significantly less. The reason for the problem is the enormous size of a 10-inch drone. This is so sluggish that it cannot rotate around an axis several times in a second. In addition, I flattened the curve to get more sensitivity on the remote control here in the middle. I also set the gas limitation to 80% here too. This gave me a better feel for the gas in the initial phase. I will come back to the window with the filter settings later in the motors tab. Now let's move on to the receiver. Here you just have to select the receiver protocol. After that, if you have connected the LiPo and connected the remote control to the drone, you should see the stick movements here. In the next tab you assign the various functions for the buttons on the remote control. For example, I placed the arm function on the start-stop button on the DJI controller. Angle and horizon are two stabilized modes. In horizon there is still the possibility of 360 degree turns, which are completely deactivated in angle. As usual with DJI, I put the failsafe function on the emergency button. So I'm done here and I will continue in the motor tab. Here I would recommend arranging the motors exactly as I did. The two front ones should each turn outwards. The two motors in the diagonal must always rotate in the same direction. Once you have finished adjusting the engines, you should remove the propellers so as not to endanger yourself. You can then activate the switch here and control each motor individually using the controls. If the direction of a motor is not connected, go to Rearrange Motors here and test everything again. Here you can now select the engine protocol and at the bottom left. For me it is D-Shot 300. You should also select bidirectional D-Shot here if your ESC supports it. The number of motor poles is usually 14. and I have increased the idle percentage slightly because the large 10-inch props otherwise start up a little harder. At this point we came back to the filter tab, which can be found under the PID settings. You can now adapt these filter settings if you have also activated bidirectional D-shot. The last thing I will talk about in Betaflight is the OSD tab. Here I have now picked out the most important functions for my needs and arranged them the way they suit me. However, it is best for you to decide for yourself which functions are important to you and which ones you want to display in the classes. Once you have finished everything, you can test the drone for the first time. I can advise you to drive to an open field and test the drone there. The tests in my garden were only to check the newly installed stack. In hindsight, these tests would not have been necessary for me, and actually more could have broken than I was able to learn from the tests. But now we are going to the test flight.
Cause you're a sky full of stars. I'm gonna give you my heart. Cause you're a sky full of stars. Cause you light up the park. I don't care, go on and tear me apart. I don't care if you do. 'Cause in a sky full of stars, I think I saw you. Cause you're a sky full of stars. I wanna die in your arms. Oh. 'Cause you get light